Greetings, my fellow descendants. It's your boy right here, K Pro, and I'm back with a brand new tutorial on conservation of linear momentum. Basically, in this tutorial, I'll be showing you how to tackle questions related to linear momentum and explaining to you briefly what is linear momentum and a mechanism that can help you remember that long formula that they don't give you at the back. Because if you can remember properly, they only give you the MPV formula. They don't give you the conservation of linear momentum formula. So we're going to get deep into that. Note something, in this tutorial, I will be showing you how conservation of linear momentum works and everything like that. I am not doing questions based on that. I will be creating questions by myself so that it can be much more easier for you to grasp the concept and go and apply it on your paper when you write. So let's get into it, guys. Allow me to write down linear momentum. Sorry about the handwriting. Right, linear momentum. Okay, guys. Now, the first thing that we have to understand here is the word linear, right? What does linear mean? Right, linear, we know this from mathematics. We have linear functions, linear graphs, everything that says linear, right? What do we know about linear, guys? What we know about linear is that anything that is linear is straight. That's the first thing that you should know about linear. Everything that is linear is straight, right? It's straight, right? So let me just say this is linear, right? It's not accurately linear, but it is linear, right? So we know that it's a line, a straight line, and all that, right? It's a straight line. That's what we're talking about when you say linear. The word linear comes from line. It means there's a line involved, right? Can you see line right there? Right. So now let's deal with a momentum over here, right? We know that momentum, we were taught that momentum is represented by P. And momentum is the product. I hope you have your pen and paper, as I usually say, is the product of mass and velocity, guys. That's what momentum is, right? So now we have a better understanding of what linear momentum means. We are basically talking about straight line momentum, guys, right? Straight line momentum. That's what we are talking about in this tutorial, right? So let's go deeper into it and try and understand everything. Right. There is a law. It's called, oh my bad. Let me just grow this again. There is a law in physics called conservation of linear momentum. They usually ask this question during June exam, prelims, even finals. It's always there. So I'm just going to touch on that briefly. All right, guys. So let's talk about the conservation. Let's conservation. Sorry, that N just doesn't look good. Let's talk about the conservation of linear P. Okay, guys, you know very well that P stands for momentum, right? Should I write it down again? Okay, let me try and do this so that it can be clear. Of linear P. There we go. Right? We know very well that P represents momentum, right? And what is momentum? Momentum is the product of mass and velocity. What is a product, guys? We learned this in mathematics primary school level, that a product is multiplication. So basically what we are doing there, we are multiplying the mass and the velocity. That's how we get our momentum right there. So guys, when we talk about the law of conservation of linear momentum, what is to conserve, guys? What is to conserve? What is conservation? Have you heard this word before? I believe so. Let me just say, I remember when I was in primary, they used to tell me about this word, and they would say conservation of plants and everything like that, which means we are preserving in a way. Like, I don't know, how can I put this, we are keeping something constant, we are maintaining. That's what conservation means, according to me. So, in most cases, they're going to ask you to state this law. So, the law says, if I'm not mistaken, obviously, linear momentum, right, remains constant. Linear momentum in an isolated system remains constant. Linear momentum in an isolated system. I'm going to try and write this, all of it, in an isolated system remains constant. Okay, guys. So now, remember I told you that when I was in primary, when they used to say, let's conserve these plants, I used to think of it as keeping something constant, right? That's what I'm saying. We want to see something that says conservation. Just know that we are talking about something being constant right there. Hence, I have constant in my law right there, right? So what this law is basically telling us is that linear momentum in an isolated system, guys, an isolated system is a system that is stationary, or it's a system that is stationary or which has no acceleration. All right, it's isolated. Think about the word isolated, right? Once I say this guy is isolated, or I'm in isolation or something, it means that I'm not moving, guys, right? I'm not doing any action. So anything that is isolated does not have acceleration. Okay, so that's what we're talking about. This law is actually very much easy to remember if you come to think of it. And so that's what we're talking about when we talk about the conservation of linear momentum, right? So we're going to move right along. We're going to move right along and now get into the raw stuff, right? So, guys, I'm going to try and make you understand the conservation of linear momentum idea even further before I can go into the equation that they don't give you in the answer sheet. All right, guys. I mean, in the question paper. Yeah, in the information sheet. Right, guys. So, what do they mean when they say the conservation of linear momentum, right? Remember I said in an isolated system, it must remain constant, guys. So, let's see. If something happens here, this side, something happens here, right? And then whatever happens here, maybe this is me and this is you. And we are fighting, right? You are beating me up. And then the result is I go home. I go home, right? And you go home in that direction. And I go home in this direction, right? What they are basically saying is the momentum that we were using to beat each other up must be constant. It must be the same as the momentum that I used to go. We must still have the same momentum, basically. Not the same momentum to go home, but the momentum that was used here must be conserved. You understand? We cannot gain or lose momentum in this case, right? That's what they are trying to say, but not exactly. But I'm just giving you an idea what they're talking about when it's saying conservation, all right? It's more or less like energy. So, like, if the amount of energy I used this side must be the same amount of energy I used on the other side, right? Just a quick example just to explain that, right? So let's get into the raw stuff. So a lot of grade 12s will tell you that there is a formula that is never given and they forget it. Wara. Okay, guys. Now, conservation of linear momentum. This is how we calculate it, right? Please make sure you have a pen and paper so that you can take down notes. So total P before is equals to total P after. Okay, guys, so what am I saying here? This is the first step into getting this correct. This is the first step into getting this correct. If you understand this, then you are set for life. Okay, guys, so what I'm saying here is the total P. What is P? My P is the momentum, guys, right? My total momentum before must be equals to my total momentum after. I just explained this a few seconds ago, right? So the momentum that I have on my left must be equal to the momentum I have on my right. So we can dissect this even further, right? So what would happen is total momentum. Now, when we're dealing with a linear momentum, usually what would happen is we're going to have two objects. They usually give you two objects. They don't give you three, okay? For grade 12 syllabus, they always give you two objects to deal with, okay, guys? So now, I'm going to make a simple example. It's a silly example, guys, but for you guys to understand and for everyone to understand, this is what I have to do. So total P before and total P after is given by M1 V1 plus M2 V2 is equals to M1 V1 plus M2 V2. Okay, guys. Now, please look at this formula. Very important. This is the same formula that you guys keep on forgetting when you're writing your exams and some of your cram. It like your teacher would usually give you maybe like 3 sets of this type of formula, but changed in a way, right? So you guys usually forget it and stuff. So, guys, this formula is always the same, né? I'm going to show you why does it change sometimes, and it's not a necessity that it changes. Okay, it is not a necessity that it changes. Now you guys have to look at this. Total P before, this is the momentum before and the momentum after. Your question is, why do we have two MV? Why do you have two masses and why do we have two velocities? Remember, guys, we will be given two objects. You are in grade 12. The maximum number of objects they can give you is two objects. So listen to me. If me and you are fighting, we will have to know what is my momentum and we will have to know what is your momentum. And what is your momentum after you go home and what is my momentum when I go home. Hence, we have this formula. Can you see? This is the normal momentum formula, guys. Do not be fooled. This is simply saying P of me, the momentum of me, plus the momentum of you while we're fighting, right? And this is the same thing this side is equals to P after. After we're done fighting, what is my momentum? My momentum of me and the momentum of you, right? This is just the same thing of you. Okay, guys? Cool stuff. Now we understand what they're saying here, right? We are trying to get the momentum that we had before and the momentum that we had after. Now, the question usually revolves around finding the velocity and finding the mass, and they give you information and everything. Now, I said to you guys when this tutorial started, I'm going to be using silly examples for you to understand this because you are a grade 12 learner. So, I'm going to use relationships, guys, right? I'm going to use relationships to explain this one. Okay, guys. So, please make sure that you've noted everything I've said here down so that when I start dissecting this with a silly example, you can understand. Okay, guys. Okay, right. Now, let's work. You have a boy. You have a boy. Yeah. I'm bad at drawing. I'm sorry. We have a boy. Now, this is what I'm going to call scenario 1. S1. Okay, guys, you don't have to know what scenario is. Doesn't matter. But scenario 1. Okay? So, what is happening here? We have this boy now, high school learner, right? we have this boy who is going that direction, right? This boy wants this particular girl in the school, right? And we both know, like, as people, when we live via different values. We live according to our own morals. Like, we don't live like everybody else, right? So now, this boy is on this journey of getting this other girl from school, right? Now, what is happening now is this girl is moving in that direction, right? But this girl is focused on her own things, right? So let me try and draw her right there, right? She's a schoolgirl. She's focused on her own business and everything like that. She doesn't care about anything. She's all about her books, and she's moving to the left direction. That's her destiny right there. This boy is going in that direction, but he wants to approach this girl, right? He wants to approach this girl, right? He wants to date the girl, right? Cool. Let's see what's going to happen. So this boy comes across this girl and they talk. They talk. This is what we call talking stage. They talk. And the girl agrees, right? When the girl agrees, now they both move in the same direction. Oh la la. Congratulations to them. Now they are both moving in the same direction. Right? There. Okay, guys. Does this make sense? Now, the question is, how can I represent this using the conservation of linear momentum formula? Right. So now, do you agree that this boy had his own mass, right? This girl has her own mass, right? This girl was going in her own independent direction, right? And this boy was also going in his own independent direction, right? Right. Now, what's happening here? Look at this. I want the momentum that these people had. This one had, I need the momentum of him while you are still independent, plus the momentum of her while she was still independent and focused on her books. And that momentum must be equal to the momentum that they have when they are together now, right? But now, because now they are together, yeah, they are moving at the same speed. Guys, how can you be in a relationship whereby you guys are not moving at the same speed? How can you be rushing for things and I'm slow in the relationship? Obviously, we are moving in the same direction, same speed, right? Right. So, since they are moving at the same speed, it means that they have the same velocity, right? So, since they have the same velocity, what are we going to do this side now? I want to show you something that is done mathematically. Now they have the same velocity, guys, right? Now, since they have the same velocity, what am I going to do to this equation this side? I am going to factorize it. Okay, let me remove factorization out of the way. We have the same velocity, which means this and this are the same. So basically, the V for both of them is the same. What is different? The difference is the masses, right? So I'm just going to say M1 plus M2 right there. Right? And this side remains the same because they were independent and now they are together. What does this tell you? If objects are now moving together, they will move at the same velocity, right? But different masses. Do you understand what was happening there? Right. So I hope this is what you should understand. This is what I call scenario 1. This is what I call scenario 1. My favorite. Okay. My favorite one. So I'm sorry guys for using relationships to explain this, but I feel like it's the simplest way to go if you want learners to understand the momentum, conservation of linear momentum, right? So that was scenario 1. You understood what was happening. Now we're going to go to more. Okay. Now scenario 2, guys, right? Scenario 2, S2. Remember, you don't have to know a scenario or whatever. As long as you understand what I'm saying here, the content, that is what is important in this lesson. Now, we still have a boy and a girl, guys, ne? Ne? We still have a boy and a girl, ne? But this one is more or less simple, ne? So, this is scenario 2, right? This boy is moving in his own direction at his own velocity. This boy is going that way, ne? And this boy wants a girl at his school, right? That way. Right, I'm sorry guys, I'm very bad at drawing, but you guys can see what is happening there. Right. Now, here's the girl here. Okay guys. Now what happens is now the girl is going that way. Meh. Now this boy approaches this girl and they talk. They talk. Talking stage, talking stage, talking stage. It's a talking stage. It's a talking stage. So now they are talking, and the girl is like, no, bro, I'm not gonna date you. You know, bro, like I have school, I have everything, so bro, I'm not gonna have this relationship with you. And this boy gets angry, right? And what happens now? Who can tell me what they think will happen? This is what's gonna happen, guys. Now the boy is gonna change his direction, right? He decides that, okay, I don't want to face this girl anymore. I don't want to see anything related to her anymore. So what I'm gonna do, I'm gonna go back to where I came from and continue living my life. And this girl says, I don't want to see that boy anymore. He wants to ruin my future. So I'm gonna just go back to where I was at the beginning. So they collide, right? And each one of them moves into opposite directions, right? Which means whatever they were talking about, they did not reach a mutual agreement and they decided to split, right? They were onto talking stages and the girl did not agree or whatsoever, and they decided to take their opposite directions. You understand? Have you ever seen when you want to do a business with somebody and you guys do not have the same values or don't agree on the same things, and you like, you know what? It's better if we take our own opposite direction or our own routes. It will be better that way. So that is what is happening here. Now, guys, I want you to notice something. This is the easiest scenario ever. Actually, all of them are easy because the only difference is that you have to factorize on one of the scenarios. Guys, here you're just going to simply say M1 V1 plus M2 V2 equals to M1 V1 plus M2 V2, right? Sorry about that one. Right. Guys, you don't have to change anything in the formula when it's like this, guys, because at the end of the day, these two people are not dating. They are not moving at the same velocity, right? They are not moving at the same velocity, and we are definitely sure they do not have the same masses, right? So we cannot keep their masses, we cannot factorize their masses, we cannot factorize their velocity. It will remain the same, okay, guys? So this is the easiest type of question they can ever give you. Remember, I'm making a silly example, right? You can easily change this boy and girl into a car and solve a question, right? This is getting interesting now. Now we're going to scenario 3, guys. If we were dealing with cars, this scenario 3, they were gonna call it they used to call it an explosion. So let's see. So now we have scenario 3. So I'm just gonna change that to 3. Scenario 3, right? Now, guys, scenario 3, more or less similar, guys. These scenarios are so similar, you don't have to even change anything. Okay, guys. So what would happen is now, this is very highly unlikely to be questioned in an exam, but it's there and you have to know it. But it's highly unlikely that you'll get such a question. So this boy is moving in that direction as usually, and this girl is moving in that direction. We have a girl there. I'm sorry for the drawing. And she's moving in that direction, right? And they get to their talking stages usually before they go into the relationship, right? And then now, what happens now with these two now is that now they decide that this is what we call an explosion, right? They date, but they end up breaking each other's hearts. So they end up finding out that they're not good for each other. You understand? So this girl destroys this boy's life, and this boy destroys this girl's life, and it ends up into a tragedy. Do you remember, those who are doing English home language, how the story of Romeo and Juliet ended? How the both of the lovers killed themselves? This is the scenario right here. So they date, but they end up killing each other. So now I call this part suicide. If we're dealing with cars, we're going to call it explosion. Right? An explosion. Okay? So what would happen here is now these two people meet and they decide to date each other. But now what happens is that they commit suicide. It leads to a tragedy. Right? So let's call it a tragedy instead. Something that you might remember from Romeo and Juliet. A tragedy in a relationship, right? A tragedy, right? That's your scenario 3, guys, right? Pretty much simple. How will the formula be, guys? Okay, we know that, okay, this side, he was moving alone and she was moving alone, no problem, right? Oh, sorry for that. What am I doing? All right. So guys, is equals to, guys, if something explodes, right? If something explodes, do we still have its velocity? No. Velocity is going to be 0. And if the velocity is 0, that means everything is going to be 0. So now this side we have 0. That's your scenario 3 right there. It's highly unlikely that they will ask you this question. A lot of learners do not understand it. Okay, so it's highly unlikely that they will ask this question. Now let's go to our scenario 4. Guys, I'm explaining everything in detail so that you can make sense of everything, guys, okay? I'm not gonna remove the boy. I'm just gonna change this one to 4. Okay, guys, as for scenario 4, guys, what's happening here is now, okay, I see what I have to do now. I have to remove the boy, right? And now this guy is married to his lady. Okay, guys, this is more or less similar to the scenario 2 or scenario 1, I think. They are married. Guys, I'm sorry for my drawing. I'm just not good at drawing, especially digitally, you know, but I'm trying. They are married, guys, right? They are married. Okay, they are married. And you know what happens now is that they are moving in the same direction. Okay, they are moving in the same direction, and now that they are moving in the same direction, they decide that they're gonna get a divorce, right? Now when they get a divorce, they go into divorce in court. Now it's no more talking stages. They divorce each other, and now when they divorce each other, they end up going in different directions. They separate, and the boy's like, I'm taking my own route, and the female is like, I'm taking my own route. So let's say this is the man and this is the female. She's like, nah, man, nah, bro, we can't do this anymore. And now they take the different route. Okay, now This is what's going to happen, guys. When they are married, they are obviously moving at the same velocity, right? So what's going to happen there? Focus, pay attention. We are going to factorize velocity, and velocity will be outside because they both have the same velocity, and then their masses will obviously be different. It's highly unlikely that they have the same body mass, okay? So there we go. Then this side will remain the way we know it. M1 V1 plus M2 V2. Guys, I hope you can see what is happening here. This is similar to the first scenario that I explained, whereby I said this thing was this side and this one was this side. Basically, they met and they decided to date. Now they were in a marriage, they were together, and they decided to have a divorce. Hence, we have this now. I hope it makes sense, guys. I hope it makes sense. Yes. Okay. I hope I've covered everything. If I haven't covered a scenario here, because there's so many scenarios, guys. There's so many scenarios, but for grade 12 reasons, I like to keep it short. Oh my God, look what I just did. Oh my God, okay. Please, guys, do not forget to subscribe to my YouTube channel as we go further into dissecting this topic and actually understanding what is going on. Oh my God, okay. What is going on? Okay. All right, guys. I'm sorry about that. I'm using Paint 3D. All right. We're going to be back just in a minute. Okay, guys. My CPU is under pressure. I don't know what's the reason behind that, though. Okay, guys. So, please do click the subscribe button and do follow us on Facebook. It's Science Masters. Don't forget to subscribe here and join our WhatsApp group. There's links in the description which you can press or click and join our WhatsApp groups. It's absolutely free, where we'll be taking questions each and every day. Right, guys. So now I'm gonna continue using red. Okay, guys. So now that I've shown you all these scenarios, I hope you've realized that this formula, here, it can be written in many ways according to your understanding in maths. But you don't have to understand maths in this case. You just have to understand life, because physics is really actually based around life. Okay, so what's happening here is we've noticed that we can factor out V if these people are moving in the same direction. Because why? They're moving at the same velocity if they are together, right? And it depends where these people are. If they were together and then they decided to divorce, which means now we're factoring out V on this side. But if they were not together this side and they decided to date this side, we are factoring out V this side, right? And if there's an explosion, there is not going to be any velocity, right? It's a bomb. It's exploding. So there will be zero. Okay, guys. So I hope you understand that all you have to know for your examination is this, right? And it's pretty much rememberable, okay? You can actually remember this. M1 V1 plus M2 V2, and then you write the same thing on the other side. The difference is now, this is for before, and this is for after, right? Very easy, pretty much easy. Anyone can do this. Okay, I believe so. So, guys, now that we know what is happening, now let's try and put all this knowledge that we've learned into actual work. Guys, I'm not going to answer an exam question because I don't want to confuse you. Now, I don't want you guys to cram this because this is easy. I'm going to create a question out of something simple. Right? Now, guys, we're going to use cars. Because that's what they're going to question you on most of the time. Cars, trolleys. So, let's use a car, guys. I'm bad at drawing. Forgive me. This is my car, guys. And this car is going in that direction. And at speed, the speed of the car, let me just say it is 5 m s -1. That's the speed of my car. It's going that direction. And what's happening is now my other car is going in the other direction. This is collision. They're going to collide, okay? So now this is what's happening now. And the speed of this one doesn't have wheels. Wow. Okay. The speed of this car now is 2m. It's 2 minutes per second. Alright, guys. Now we have these two cars, right? One is moving in that direction and one is moving in that direction. And then something happens here. They collide, okay? When they collide, after they collide, this one, okay, let's call this one A. Let's call this one car B, right? And after collision, car A actually goes that way. Sorry about that. Car A goes that way. And car B goes that way. Okay, hope you can see that. All right, guys. So the mass of car A is 10 kg. 10 kg. I'm making an example, guys. I know a car cannot be 10 kg. All right. And then the mass of this one is unknown. Okay. Now we have everything about this, right? So now the question is, find the mass of car B. Okay, so you must find the mass of car B, guys. Okay, guys, so now the question is going to be actually, how are we going to do this? Now I'm going to show you the necessary steps that you have to take into answering such a question. Okay, guys, so we are looking for mass, right? First things first that we have to know is that the total, I usually write it like this. The total, this means sum. You know this from sigma notation. P before. This just means, don't worry about this. This is what you find during sigma notation. It means sum. Sum and total, more or less the same thing. The sum before, or the total before, must be equals to the sum after, or it must be the same as the total after. Right? The total of what? What does P represent? P stands for momentum. Okay, guys. It's gonna be nice now. It's gonna be nice. Alright, guys. So now, let's see. Now we are finding the mass, guys, right? This is gonna be so much easy. I want you to take out your calculators and be ready and be focused. We have car A and car B, right? So they're saying, what I do is that I usually say, okay, since they said it's car A and car B, I'll come here and say, this is my car 1, this is my car 2, right? Even this side, this is my car 1, this is my car 2. Step number 1, before you can continue, you have to choose direction, okay? You have to choose whether you are taking this direction as positive or that direction as negative or what, okay? So what I usually say to my descendants is, the direction, let the direction of the first body or the first car or the first object be positive. So what is the direction of A? It's going to the right, right? So let's say right will be positive, okay? Let's say A is moving in a positive direction, okay? So we're saying this one is moving in a positive direction, this one is moving in a negative direction, right? Which means any motion that is going this way is in a positive direction, and anything that's going that way is in a negative direction, which means this side, my car A, is in a negative motion, and this side it's in a positive motion, right? So now let's see. Now we can write our famous formula, our easiest formula ever. V1 plus M2 V2, right? Which is M1 V1 plus M2 V2. Okay, guys. Now we have to, I need you to take down notes on this and record or note down whatever is happening here, right? Now that we've written down this, when they mark, right, they're going to mark this two things as one mark. So this is actually one mark at the exam center, right? Just for understanding and for analyzing what is happening here, you are getting a mark, right? Cool. Shall we continue? I think so. So now, guys, before I substitute anything, right, I need you to understand that when we substitute anything in mathematics and in physical science, we open brackets. Why? First of all, it's to keep tidiness, and first of all, it's also to make sure that our signs are correct. Because if you just substitute, there's going to be a confusion of signs, and you might end up getting a negative mess instead of a positive mess. Okay, so guys, keep that in mind, right? So I'm going to remove everything here, and okay, let me do this. I'm going to create an external project using this. So what I'll do is, so that I can recall this action, I'm going to try and access another window. I don't know how I'm going to do this, but yeah. Let me try and do a screenshot first. Where is it? Screenshot. Seems like I can't find my screenshot app. Okay, guys. I don't know how I'm going to do this, but please bear with me. Okay? Please do bear with me. I'm gonna do it right here, right? I'm gonna try and be as quick as possible. We have the mass. I told you that this is my car 1, car 2, car 1, car 2. So what is car 1? It's A right there. So what is the mass of my 1 there? Right? The mass is, just look at me properly. My mass is given as 10. Now remember I said when you substitute, you open brackets, right? What is my velocity, guys? My velocity is 5, right? But now, this 5 is going into the positive direction. So which means my 5 is positive. So I'll put plus 5, right? Direction works because we have to include it when we're dealing with what? The velocity. Now, what is the mass of the second body? We do not know. That's what we are looking for. So, what are we going to say? It's M over there, right? Brackets. What is the velocity of body B? Now, pay attention now. It is moving at 2 ms, right? It's fine. It is moving at a speed of 2. Now, guys, we can see that this body is moving in a negative direction. That means my velocity must also be negative 2 right there. Okay? Which is equals to, now this side. Okay, something that I didn't do right here. I was supposed to give out the velocity as well for this side, right? So what they could tell you is that the speed of the car this side could be 3. And this side, it could be 5. Right? I hope you guys understand what is happening here. I'm trying to write neatly, but ish. MS. Bear with me, people. Okay, guys. So you can see now that they gave you the velocities after, and we know very well that the mass does not change. Even if you can beat me up, my mass will not change. Believe me. So I still have the same mass for car A, right? And what is that mass? Remember when you substitute, you open bracket, it's still 10. What is the velocity now? We have a new velocity, which is 3. But now look, this car A is no longer accelerating in the positive direction. It's now going to the negative direction. So now I'm going to have a negative 3 there. Okay, let's see what's gonna happen now. Now we're looking for the mass here, guys. Ne? The mass. We don't have the mass of this. Do we have the velocity of this now? Yes, we do, which is 5, but now it's moving in a positive direction. So now I do not have to put a negative sign, but I have to put a positive sign because it's going to the positive direction. There we go, guys. Now from here, physics is done. From here, it's now mathematics now. This is basically an equation, and you are used to doing this. All you're going to have to do now is to multiply the brackets and then make m the subject of the formula, and then you solve, right? I believe everyone can get the answer from there, right? Because I don't think I have enough space to solve this. But basically what you would say, you just say 10 times 5, which would give you a 50, right? And then what you would say, m times negative 2 would give you a negative 2m, which is equals to 10 times a negative 3 would give you a negative 30, right? And m times 5 would give you an m 5m. Okay, my bad. 5m. And then what would happen is that you transpose like terms as you were taught in grade 8. So this negative 30 would come that side, and this would go that side, right? Now what would happen? It will be 50 plus 30. Now you'd have 80 this side. Come with me. It's now 80. And that side, you would have 5 plus 2. Now you'd have 7m. Okay, guys? Then what you'd have to do is just divide both sides by 7. Divide both sides by 7. And whatever you get from your calculator, 80 divided by 7. M is equals to 80 divided by 7. But the mass is in kilograms, so kg. Never leave it in fraction form. Please take your calculator and find out what is the answer there. So that's the end of the question. We have solved for the mass. Right? We have solved for the mass fully. Okay, guys? We have fully solved for the mass. Right. So this is what I wanted to show you guys today, because a lot of learners have a problem with this. Next, I'll be doing a video on, I believe people have been asking me about the impulse and the FNet. And I'm just going to show you how we can use vertical projectile motion. Or let me just say how vertical projectile motion or equations of motion coexist with linear momentum or conservation of linear momentum. But for today, this is what I wanted to show you. This is usually 5 to 6 marks, guys, and I believe everyone can score this in their exams. Good luck to those who are writing their exams, whether it be tomorrow, next week, or next month. Please keep on studying, keep on revising. Physics is an application of life. Physics is life. It's something that you see every day. Therefore, you can come up with practical examples to understand topics. Please do not stop practicing physics each and every day so that you can get better and better at it, right? I created scenarios so that I can understand a lot of things in physics, because I found it very hard to understand things that were put or set out in the textbook, guys. So do the same thing, and I wish you nothing but good luck in your forthcoming exams. Please do not forget to recommend me to your friends. I will be hosting cross nights at the end of the year. I have a WhatsApp group where I'm adding everyone who's interested in those cross nights. I have a Facebook page called Sci Masters. Please do subscribe to my YouTube channel for more content. I will be doing each and every question that you can ever think of in Matric, guys. Okay, mostly for physics, for mathematics, for life science, for English home language. You know, just making sure that you guys get those marks that you guys want. So let's work, guys. Peace. Felice, dog.
I want to go to the city. Yeah.